we're gonna go through two examples. I want to do one exponential. I want to do one log, and we'll come back to the end at the end and do some more stuff with graphing. But I'm gonna go ahead and graph this. Let's look at the what's my parent function going to end up being here?
4x.
It's y equals 4 to the x. Don't say 4x. It sounds like 4 times
Okay,
x.
whatever, that's better.
Okay, I know. So we're going to have our original points. What's the original points for this one?
-1, 0, 1. And then goes 1/4, 1, and then 4.
Good. And we know this because they're just reflections. It's just inverse of the logarithm graph that we've been working on so long for the last couple of days or last week or so. My new graph, my new coordinates is x, y. What's it going to be? Now, one of these is simple, one of these is not so simple. Okay, let's go ahead and do the x changes first because that one is really straightforward. What happens to x here? So I'm just going to subtract 3. So -1 minus 3 is -4. 0 minus 3, -3, and -2. So that's pretty straightforward. We want to go ahead and we want to change y to. Tell me what's happening to y.
It's going up, no, down 1.
Down 1.
And then multiply by 2.
And I'm doubling and
Change the sign.
changing its sign. The question is, if I've got all three of those things that are happening all at the same time, how do I apply those to the numbers? Because if I shift and then reflect, or if I reflect, then shift, I'm going to get different numbers.
I have a question.
Yes, ma'am.
If it's in front of the 4, then what do?
You're going to be changing the y value with that number.
With
Like the -2, the -2, it means I'm going to be
changing the y.
the y.
But what about if it was in front of the 4?
That is in front of the 4.
The equation at the top. If it was a negative sign in front of the 4 instead of.
Oh, that would just be like a decay function. We're not going to do that.
When do you flip it across the x?
When the x is negative. No, when the y is negative like this, when there's a negative out in front of the whole thing like this, then you're going to reflect it over the x. Okay? If the x were negative, if you were to look at one of your other examples, let's say like number 3. Number 3 has a negative in front of the whole thing, and it has a negative x in the exponent. That means I'm going to reflect it over both the x and the y-axes. So when I go to change my coordinates, I'm going to be changing every single coordinate sign, x's and the y's. Let's go ahead and let me give you 2 ways to do this. If you're ever in doubt or you're really not sure which way you should apply these, please remember that you can take these x coordinates, -4, -3, -2, and you can plug those right into the equation and you can work it out. Okay? Now, if you want to know the correct method, we're going to go ahead and we're going to multiply by -2 first, and then we're going to add our 1, or subtract our 1, excuse me. You're going to multiply, order of operations, we're going to multiply first, and then we're going to subtract at the end. Okay? But you can double check that by just plugging in the number itself. For example, let's just say we're just going to plug this in. So we have -2 times 4 to the -4 plus 3. And that's going to be -1. What does that give me? What's -2 times 4 to the -1 is 1/4. Minus 1 is -1.5. Because you get -1/2 minus 1. And if I actually do the same thing, if I take my -4, if I multiply by -2, or take my y coordinate, my 1/4, and I multiply by -2, and I subtract 1 from it, what do you think I'm going to get? I'm going to get -1.5. So -1.5 here. Let's do -3. If I take my 1, my original y value,
It'd be -1, right?
no, I think it's going to be -3. So we're going to take 1.
Wait, I thought we
I'm going to multiply by negative 2. So negative 2 minus 1 gives me negative 3.
Well, I thought we didn't have to plug them in. I thought we just had to kind of.
I did that one by not plugging it in.
Okay.
I said I'm
That's
going to
that
multiply
one?
by negative 2 and then subtract 1. That's exactly what we did to the y. So I took my original y value. Let's do number 4, or the fourth one like that. 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9, which is correct. If I were to plug negative 4 into x, I'm going to get if I plug negative 2 in for x, the x coordinate, then it would happen to give me the same thing.
What you can do is just do y times negative 2 minus 1.
Exactly.
That'll give you.
Exactly. Okay, so I've got my new coordinates. Let's go ahead and graph this.
What is the I thought you had to change the sign.
Why didn't you tell us that before?
Okay, hold on. I didn't.
A lot easier.
Yeah, I know. That's why I'm telling you now. But Megan, what did I multiply by?
-2.
So when I multiply by negative 2, I'm changing the sign and stretching it. When I subtract 1, I'm shifting it down 1. So it's all built in. If you look at the equation, it's just telling you what to do with it.
If the number happened to be already negative, if the y value happened to be already negative, and you multiply it by 2, by negative 2,
What is that?
Then it would be
become
positive. That's right.
So it would go ahead and do it.
It would switch your signs yet again.
What is that?
You hear that?
It's the ceiling vibrating.
Why?
That didn't go ceiling.
Yeah, why is it vibrating?
The fan's running. That's why.
Yeah, it's
So.
getting kind of cold.
I don't like that.
It's not fun.
Here we go. Let's graph our. What's our asymptote here? Asymptote, please.
It
See,
is
we're all electric. The next person.
-3.
Negative 3.
I touched more of
Oh,
What's my asymptote, ladies and gentlemen?
I guess.
Exponentials deal with the vertical shift, so it's negative 1.
So, what is
Shh.
the negative 2?
This is not.
This is decreasing, right?
It will be decreasing. Listen carefully.
So it's -1, right?
It is
There we
Okay.
Are you
go.
recording?
Yes. Listen carefully. Shh. In an exponential, if you don't remember this, then you need to have written this down or write it down now. Exponentials, the vertical shift is the asymptote. In logs, horizontal shift is the asymptote.
Exponential what?
In exponentials, the vertical shift, up and down motion, is going to tell you the horizontal asymptote. In a logarithm, the x part, the inside, the horizontal shift, tells you the vertical asymptote. Did you get that? Exponentials, you're looking at the vertical shift. Logs, horizontal shift.
Horizontal shift tells you the vertical asymptote?
Yes.
Okay.
It's kind of backwards from what you think. So let me go ahead and graph this. This is negative 1.5, negative 3. So negative 1.5, 1, 2, 3. So it's about right here. Negative 3, 3. So negative 3, negative 3. About there. And then negative 2, negative 9. Oh, I got 1 point wrong. Let's see. We have negative 4 would be right about there. And negative 3, 3. Right there. And negative 2, 9's. I can't graph today. Negative 4 on the x. Negative 1.5. Right about there. Let's try this again. Negative 3, 3. Y'all can correct me anytime.
We do.
And then negative 2, negative 9. That's about right there. So you can see your graph go like
I
that.
don't understand how you got the new points. Like, I know you have to do the -3 and then the -1.
Well, see the 2 out front and the negative 2, actually?
Yeah.
When you find your y value, you're going to take your original y value. Let's do the fourth one, right? So if you take the 4 here, okay, I'm going to multiply by -2 first, because you're outside the -2 part, and then I'm going to subtract 1 to get the new y coordinate, which would be your -9.
You don't do that to the x though?
Well, the x, which part of that's changing the x? Just the +3. So I'm going to do the opposite for the x. We always subtract 3 from that.
What does the -1 do?
The -1, remember, it applies to the y. In an exponential, anything that happens in the exponent is going to affect the x. Anything that happens outside the exponent is going to change the y. So let's kind of walk through all of the pieces that we had to do here. And so the first thing was domain. That's pretty easy. What's the domain of this problem? Domain would be all real numbers. Good. And the range?
X
Lower
is
than.
less than -1.
Good. Y is less than -1.
Asymptote must be -1, coach, not 1.
How did that get disappeared?
Yeah.
Thank you.
For exponentials, will range always be y is less than, and then
Shh.
will they always be domain and x is greater than?
If it goes up, it's going to be greater. If it's going down, it'll be less. We've got the asymptote drawn in. This is increasing or decreasing?
Decrease.
Is decreasing. And what's the interval that it decreases on?
Negative infinity to infinity.
How do you do that?
You look at your range, your domain. When you go to look at your interval of increasing and decreasing, you'll tell me increase or decrease. Or you could say growth or decay. Either one would be fine. Whenever you write that interval, you're going to look at the range. I mean the domain, because intervals of increasing and decreasing are always written in terms of x. So I go ahead, I look at my domain, because these are all, either it's all increasing or all decreasing. So it's over the whole thing. So that means that your domain is going to be the same thing as that. Negative infinity to positive infinity is another way of writing all real numbers. I mean, technically speaking, for exponentials. For exponentials, yes.
So for
It's always going to be
Yeah.
decreasing or increasing to negative infinity.
Right. In behavior. What do you think the in behavior is going to be?
it's y
So we have f of x.
F of x goes to negative
approaches
1.
positive.
F of x, let's say x is, let's do this, as x goes to negative infinity, what's happening to f of x? -1, very good. F of x is going to, as x goes to positive infinity, what's happening on the right side of the graph?
Negative.
Negative infinity. Okay? Let's talk about x and y intercepts for a second, and we'll be finished with this. Which of those intercepts do you know that do not exist here?
X.
The x-intercepts do not exist. Why do we know that?
Because the asymptote is under the x.
Very good.
Axis.
It's going down. The asymptote is below the x-axis. There's no way for me to get above that.
That's the points.
Okay? So the x-intercept doesn't exist. What about the y-intercept?
Plug in 0 for x.
We're going to plug in 0 for x. And so we'll do it right here. So you have 0. You have y equals -2 times 4 raised to the third power minus 1,
Is that 64?
which is -129. So what's the coordinate for my... Good. 0, -129. Okay? Really far down there. Okay? Questions about exponential graphs? You're going to have a couple of graphs. So you actually have 3 graphs that you have to graph yourself. There'll be a combination of either exponentials or logs and the growth or decay. So a mixture of those out of just 3 graphs.
Earlier you were saying that when like the 2, like if there's a negative there, that'll be a flip over which axis?
If it's out front, it's reflecting over the x-axis,
And then when
right?
it's with the exponent, like X.
It'll be reflecting over the y-axis. So you can look at this one. Normally, you have exponential graphs that look, exponentials naturally want to look like this, right? That red graph is what a natural exponential, but I've reflected over the x-axis, and now it's below it. That's where the reflection comes from.
Coach, I have a question.
Okay.
So does that thing where you can just plug in the y and find the new y, does that work for logs too?
It works for everything. It's just sometimes logs are a little trickier because we can't always just work a log out. If you remember that change of base formula, then yeah, you can. Log of the top part divided by log of the bottom part. Because sometimes you might get log base 3 of 6.
Log of the top part.
Remember what I told you on the board the other day?
I don't think I was.
Okay. Shh. Yeah. Let's make sure that we all remember this. Shh. If you have log of base 3 of 6, and I need you to tell me what that number is. Maybe you're trying to find the inverse. Maybe you're trying to find like an X or Y intercept. And so 3 to what power is 6? I have no idea. 3 to the first power is 3, and 3 squared is 9. And so it's not perfect. Maybe it's 1.5, maybe not. I don't know. They're not always going to be nicely worked out. So here's the formula you change that to. It's log of 6.
Over log of 3.
These are the common logs. Log base 10. I don't care what the original base was. I need to be able to plug this in my calculator. So what we can do is we can take any time you have a logarithm that has something that doesn't work very nicely, and I need to get that decimal approximation, say for an X or Y intercept, then this is how you find it. Log of the top number divided by log of the base. And that I type into my calculator using my log button, L-O-G, and it'll give me that decimal approximation. Okay? If it's a perfect number, even if it's a perfect number, it still would work. Like, let's say that you had something like log base 4 of, say, 16. And you did log 16 over log 4. That would still give you 2.
It's 1.6.
Okay. The first one is?
Yeah. 1.63.
So here again, not like you think it's exact. It's close, but not perfect.
I was just thinking of random whack at it.
Okay. It's close. Now, shh. I want to talk about number 7. Shh. I want to redo this one. Yesterday we talked about it. I had a better idea.
Is that the one that you invested the
Yeah.
pieces on?
Yeah. I want to correct that. Shh. All right. Number 7 looks like this. Shh. Listen carefully. Shh. Listen carefully. On this one, writing out what happens to x and my asymptote is tricky. Okay? It's easy. I know we did this yesterday. I need to correct a few things.
Oh yeah.
The points we did were fine, but the asymptote was messed up, and when we went to graph it, there was a few things I need to make sure that you know about.
We know we didn't do this one yesterday. We did the one. No, we did the other one that has the negative log.
Okay, well, let's do this one. Same idea. Shh. Here we go. The parent, you're going to have x and y. This is the parent's just going to be log base 3 of x. So we're going to have 1/3, 1, and 3. We have -1, 0, and 1. Just like always. When we go to do the new one,
You gotta factor out.
no, I'm going to give you a different idea how to do it. Easier, less work to do. So better on both accounts. In terms of the y values, what's going to change for y? What are we going to do to y?
You're gonna add 3, you're gonna add 3.
I'm just going to add 3 to every y value. Let's go ahead and take care of that.
2, 3, 4.
Okay? Here's what we're going to do to x and my asymptote. Normally, naturally looking at this equation, what does the -4 usually tell me to do? I'm going to shift to the right first. I'm going to add 4, and then we're going to change its sign. So what I need you to do is do the shift first and then change the sign at the end. So let's do the first one. If I do 1/3 plus 4, you get 4.33. Change the sign.
That's easy.
Okay? The next part, we say 1 plus 4 is 5. Change the sign. 3 plus 4 is 7. Change the sign. Okay? Let's draw this in. Actually.
Draw the line, change the sign.
Yes, ma'am. Yes. For the x, if there was a negative out front of the log, I would change the y value. Look at the last one, number 8. You would change both x and y signs.
I have a question.
Yes, ma'am.
When we did this, when you split up like the negative and then the x minus 4, what was that?
That was something that you can do it that way too, but you have to think about it a little bit differently. I would rather you do it this way because this is quick, easy. Shh. What's my asymptote?
I'm amazing.
No.
Logs are inside.
Negative.
Negative 4.
Shh. The log, normally, when you look at the inside, you say, oh, it shifts to the right 4. So that would tell you the asymptote would be positive 4. But we have to reflect the asymptote also. So it's still negative 4. So x equals negative 4 is your asymptote. Okay? So if we draw our equation in, so we're going to graph it like this. We're going to say negative 4.33, y is 2.
Oh, it's going to be on the right side of the left side of the asymptote?
It's going to go like that. So we go over here and y is 2, so somewhere like that. Okay? Negative 5, go up to 3, so somewhere over here. And then 7, negative 7, 4 will be somewhere like this.
So to find the Y-intercept, you plug find the X-intercept, you plug in 0.
So that means the sign of the domain is split.
Shh.
Right?
Listen carefully. Let's write the domain for this. Shh. Domain is going to be what? No.
No.
That's for exponentials.
Greater than or less than negative 4. All real numbers less than negative 4.
It's going to the left, so I have to say less than.
Range is all real numbers.
Okay, yes. Range is all real numbers. Our asymptote we've got written in, x equals negative 4. So that was easy.
Do the X-intercept.
Okay, let's go down the list. Increasing or decreasing?
Decrease.
It's decreasing on what interval?
Negative.
Negative infinity to what? Look at your domain. Look at your domain. It's the same thing. Okay, in behavior. F of x goes to what as x goes, we'll let x go to negative infinity first. What happens now on the left side of my graph? What's y value going to?
Negative 4. Or wait.
Wait.
Positive infinity, you're right.
Do this together.
Shh. Yes.
Okay, how did you?
I went x goes to the left. What's happening to y as we go down to the left?
So the left is going
Up, right? It's positive infinity.
Wait, X
So we
goes
write
to
infinity,
Yes, it is.
X goes to negative 4.
and then the other one.
Shh. X, as we go to the left, x goes forever to the left. But x cannot go to the right forever. X has a barrier. It cannot pass the asymptote. So x will only go up to, but not including, negative 4. As we get closer to the x value of negative 4, what's happening to the graph?
Negative is
Going down.
Down, so that translates into negative infinity. If you say the word up or right, you're talking about positive infinities. If you say the words down or left, you're talking about negative infinities. Okay?
Infinities.
Last part was the intercept pieces. Which intercept do you know does not exist?
Y.
y.
So the Y-intercept would be none. X-intercept. Plug 0 in for x, or for y, excuse me. And so we'll say 0 equals
Log 3 times negative x
So this is a lot, just to kind of clue you in on, this is a lot like finding the inverse, except we only have one letter, one variable to solve for. So subtract 3, good.
Equals log 3. Take the log away.
3 to the
The
1
y
third to the third. 1 ninth.
Take the log away.
Switch, right? Don't you switch
Show
them?
the negative 10
1
equals
ninth.
x minus 4.
Equals
Why is it to the negative 3?
Wait, do you switch them or what?
Shh. Here we go. Watch carefully. Shh.
Over here.
Up here, watch. When you have this base,
Yeah.
and you raise it to that power. Do you understand? It's always the base. Shh. You're going to take the base, you're going to raise it to the power on the other side, and it's going to be equal to whatever's inside this log, which is what we have. Does that make sense?
Yeah.
What's next?
Plus 4.
1 ninth.
Oh, 1 9.
So, is it 1/9?
Yeah.
1 9.
3.
What's 3 cubed?
127.
So that you got, it's 1/27th, right? So we have now 1 over 27 equals negative x minus 4. What now?
Plus 4.
So we have 4 and 1/27th equals negative x.
Negative 4.
Negative 4.03.
0.4.
03.
Close enough. Okay, so what's my actual x-intercept coordinates?
Negative 4.03, comma 0.
Comma 0.
Okay, very good. That's a great example. Okay. What's 3 cubed? And it's negative exponent, so you flip it over. 3 cubed is 27.
And then you divide by negative 4, right?
No, it's added 4.
4 and then divide by negative
Okay.
1.
We divided by negative 1. Shh. So this is how you would approach a logarithm equation.
I have a question.
Let me back up for a minute. Okay. Let me recap for just 1 second. Log of a negative number is what? Not possible. I don't care what the base is. It's not possible. When you have the base of the log equal to the base of the number you're taking the log of, your answer is just the exponent. Okay? In number 3, we have 3 raised to the something equals 1 over 243. Well, let's rewrite that. 3 to the x equals 1 over 243. How do we think about that?
It's a negative, so you can't do it.
What? No, it's not negative. 1 over 243 is not a negative number. If 1 over 243 was negative, I would say not possible. Let's rewrite that. That's really 1 over 3 to the 5th power, which is the same thing as 3 to the negative 5. So what's x? Negative 5. Okay, and then number 4. 4 raised to what power is 64? That's easy. That's
Figuring them out, that's what I was doing.
4 cubed. So x would be 3. And for the most part, they work. If you get that negative 16 at the top, you're going to get to a point where you're saying, oh, something's weird. It's not working. Don't force it to work. And try to remember that conversation we had. Questions on 1 through 4.
Is number 5
Let's do 5. These are inverses. So remember, the first step of an inverse is to isolate the log. So we're going to say y divided by 10 equals log base 3 of 4x. What's next?
Then you had to raise y to 10.
Convert to exponential power. Okay, so what we're really going to do is we're going to take this 3 and we're going to raise it to this power, and it's going to be equal to just what's inside the logarithm. So we'd have 3 raised to the y over 10 equals 4x. Now I switch x and y. Very good. And so we're going to get 3 to the x divided by 10 equals 4y. And last step, divide by 4. That cancels, leaving you with 3 to the x divided by 10 all over 4 equals y. So that's your answer there. Whoa, undo that. Okay, number 6 is going to work a lot the same way. It's going to have one little extra step at the end because I'm going to have a negative exponent. I need to get rid of that negative part. So let's work through this one. So we're going to say y divided by negative 6 equals log base 2 of negative 2x. We're going to change that to exponential. It'll be 2 raised to the y over a negative 6. So right here you can see I've got my negative exponent. I've got a negative inside that, so I'm going to have to get rid of that somehow. So 2 to the negative x, or sorry, 2 negative 2x. Let's go ahead and change my x's and my y's. 2 to the x over negative 6 equals negative 2y. Just like last time, we're going to divide by negative 2. Right? And this would end up giving me 2 to the x divided by negative 6 over negative 2 equals y. But we don't like to leave a negative exponent, and it looks like we have similar bases that we might be able to simplify to. So let's go ahead. How would I get rid of that negative exponent? If I'm trying to do that, you've got that negative 6 right there. How do you get rid of a negative exponent? Bring it down to the bottom. Whenever you have a negative exponent, if you just move it to the other place in the fraction, the negative goes away. So we're going to go ahead and we're going to say that that's 1 over negative 2 times 2 to the x over 6 equals y. I could take this a step further, but we'll stop right here since that's good. Since I have bases that are the same 2's, we could actually add exponents here, but I'll leave it. Okay, so this is your final solution for that. We have a graph that has an asymptote at negative 2. We have the graph looks a lot like this. You have a point up there, that's going to be 16. Okay, and what we want to do is we want to talk about the equation, which is y equals 1/2 times 6 to the x plus 2 minus 2. Tell me domain. What's the domain for this? The picture. Here's a more detailed picture on the board. Good. It's all reals, right? It goes up and or it goes left and right forever. What about the range?
X is greater than negative. I mean, y is.
X is y is.
Y is. You confused me. Negative 2.
Negative 1.
That's negative
I just kidding.
2.
Negative 2.
You call me the fool.
Shh. All right. Quiet, please. We're going to go down domain. You got range. What's my asymptote?
Negative 2.
Y is equal to.
It's y equals negative 2. All right. The next part we talked about was increasing and decreasing. What's this one doing?
It's increasing.
This one's increasing. What's the interval it increases on?
Is it negative 2 to infinity?
Look at my domain. Look at my domain.
Infinity to infinity.
Good. Domain is all real numbers. That means negative infinity to positive infinity. The next part was in behavior. So we have f of x goes to, and we have x goes to. Let's go ahead and write that out. For when my domain is negative infinity to positive infinity, your x here's are going to be both that, negative infinity and positive infinity. So we're going to go ahead and write that in. What are my f of x going to as we go left and right here?
Well, your f of x on the net
So the left side.
is going to be negative 2.
Very good. Goes down to negative 2 on the left side. On the right side,
Then your f of x
Infinity.
goes to infinity.
it's going all the way up to positive infinity. All right, let's talk about the Y-intercept. I kind of told you this one.
There is none because you have
Y-intercept. Y-intercept. It goes up. It does actually hit it. So it's going to be 0, 16. That was actually one of the points given to you. What about the X-intercept part?
there is none
Careful. Shh. Shh. Look, right here. I'm pretty sure it goes through the x-axis. So, how would we find that? So we have y equals 1/2 times 6 squared minus 2. So 6 squared is 36. 36 times 1/2 is 18. 18 minus 2. Hold on, time out. Back up. Yeah, good call. So we would do 0. No. Yeah, I'm finding X-Intercepts. So 0.
There will be a brief meeting today after school for all students trying out for the golf team. Please meet in Coach Johnson's room immediately after school. All prospective golfers are...
You work this one backwards, just like you did. You add 2. This is number 9. How to graph with fractions. Check this out. If you want to watch this video online,